Yes.
All right, cool. All right, welcome. I'm Jean Lapierre, I'm Senior Director of Advanced Technology. For those that do not know me, maybe you're disappointed. Jean is actually a guy. Sometimes gets that. French Canadian. I was involved with ST2110 from pretty much the very beginning, longer than I can remember. I worked both on hardware and software solutions for ST2110 at Matrox. I participated in the JTNM tested program, helped with that, and I'm currently a co-chair of the VSF IPMX working group, and it's in that reason why I'm here today. So today's presentation will try to answer some of these questions. These are typical questions I hear all the time when talking about IPMX with folks. At least those questions that relate to IPMX and networking equipment required to do AV over IP using IPMX. So things like, do I need to build a new network, or can I really use any network switch for doing AV over IP with IPMX? And things like, well, I heard that I'm going to need a PTP Grandmaster, and those things are expensive. I also heard that if I'm using PTP, I'm going to need to use network switches that has special PTP mode, PTP aware switches that support boundary clocks and things like this. So we're going to try to cover these things. Hopefully when we're done, you guys have a better understanding and are able to answer the question for yourselves. And so before we get into answering those questions, let's review briefly some of the features of IPMX, since they do relate directly to what kind of network you're going to need to build to support IPMX. So unlike SDI, for example, where you have a 3G SDI cable that can carry any signal up to 1080p 60, IPMX itself can carry anything, mix and match things. That's the beauty of IP. So in IPMX, we use networks, and networks carry packets, and packets can carry any kind of video. And so IPMX is really resolution agnostic. You can do HD, you can do 4K, you can even do 8K. IPMX supports visually lossless compression. So one of the things I see often is, oh, well, if it's compressed, it's got to have high latency. Well, the compression that we use in that we support in IPMX does not mean high latency. Like total latency of less than 1 millisecond can be expected with the kind of compression that IPMX supports. But IPMX also supports true uncompressed video. That's even in 4K. So it's important to understand that for those customers that for who any kind of compression is out of the question, it's important to understand you can do compression, but you can also do totally uncompressed video. And so now that we understand a bit more the flexibility of IPMX, we can start to answer those questions. So IPMX works with basically a wide range of network speed, anywhere from 1 gigabit to 25 gigabit, anything in between or beyond. And so with IPMX, it's actually possible to use existing Cat5e cable if that's required. It really depends on the needs or constraint or the budget you have for your installation. For example, if you're distributing HD AV content and it's imperative to use the existing facility because replacing the existing infrastructure is not in the budget, while the IPMX low latency compression will let you use the current Gigi network, for example. So you can use compression also even if you have a 10 gig network. That can be useful to build a solution where lots of AV content needs to get into a single device, for example. And so even though a 10 gig network might be in use, it's important to understand that you can mix and match uncompressed, compressed content. It really depends on the need for your setup. So the point I'm trying to make is with IP and with IPMX, you get a lot of flexibility. So we saw that IPMX supports a wide range of network speed. So does it mean you can use just any kind of network switch? So that was our first question. So what about, for example, using a consumer grade 8-port gigabit switch? Well, if your network is really small, I suppose you could do that. So most AV networks that have multiple monitor displaying the same content will use multicast to reduce the traffic and the load on the sender. So in the example I have here, there's one sender and 3 receivers. So everything's connected to the same switch, for example, a really, really small network. I think even a consumer grade switch would do the trick. Like in general, basic consumer grade switch don't support multicast routing, for example. And most of the time with IPMX, you'd probably be using multicast. And so the consumer grade switch, what they do is they'll flood the multicast traffic to all ports of the switch. So if your receiver and your senders are connected to the same little switch, your receiver will receive the content and things would actually work. But that's not a very good design, and any other device connected to that switch will also be flooded, including any other switch that be connected you further on the network. And so you probably don't want to do that. But even though this would work, you most likely will want to use a switch that actually supports multicast routing. So can I use any kind of switch? Kind of, depends on your setup. But in general, I would say switches that can at least do multicast routing will be required. A little review of IPMX flows and now IPMX separate essences for transmission over a network. And why do we do that? By the way, it's the way 2110 does it as well. It's to save bandwidth and the complexity on devices. For example, if you have a device that only need to process the VANC, because they're like a VANC inserter or something like that, it's kind of troublesome to have to send the whole video. Let's say you're doing uncompressed video, be sending uncompressed video, uncompressed audio, VANC data to this device that only cares about the VANC. It needs to extract it and stuff. And so the idea here is that we separate the essences. So video, audio, and VANC will be sent to different flows on your network. That would allow you to route audio to audio devices, but it still lets you route video and audio content to devices that need both. And so what happens is there's timestamp in those flows, and those timestamps are used to recombine video, audio, and ancillary data together. So let's look at how IPMX use those timestamps in more detail. Here we have an example of one sender sending flows to one receiver. And so the IPMX sender uses its local clock for timestamping, and all the essences from that sender, they share the same clock. And so the receiver is able, because the receiver knows that all these essences share the same clock, it knows it can use a timestamp to realign the content. So in our example here, video and audio and ANC would be transmitted, and they would all have a timestamp saying, this is the data for 3 o'clock. And so the receiver can take the packets for 3 o'clock from the video and the packets for 3 o'clock for audio and match them together. And our video monitor, the receiver is able to present the video, the audio, and the ancillary data perfectly in sync. And by the way, for those that are wondering, this is done without using any PTP, right? So the local clock is used for the timestamping, and it's doesn't need PTP to do that. Let's look at here a different example. Here's an example where we have multiple receiver connected to the same source through the network. This is really to illustrate that you can have many receiver and as many as you want. If you're doing multicasting, then the source is sending one packet for video and it's distributed by the network to all the different senders. And that's the main reason why we usually use multicast for sending data. So illustrate, so the video and audio and VANC on each of those monitors will be perfectly in sync because the receiver will be able to take the audio, video, and VANC, like I explained before, and sync them together. And each receiver will receive the data, align it, and present it on the monitor. I'll take the opportunity to point out that the vSync on those monitors might not be perfectly in sync between those two monitors. The reason is that at this point, the receiver will receive the data. When the receiver receives the data, even though it knows the video and audio and VANC go together, maybe the yellow receiver received all those packets at 305, and because of network latency that are different between the two receivers, the green one might have received it at 306. So there would be an offset as to when they physically display on the monitor. Of course, if they're both connected to the same network switch and the senders also connected there, then the difference in time the receiver received the data, they'll virtually receive it at the same time, and so their sync will be aligned pretty well. And again, there's still no PTP in this example. And so here I have a different example where we have a single receiver that receives feeds from multiple senders. And so still the receiver has all the info it needs to make sure it keeps the audio and video in sync for each individual sender. So the blue data would be displayed on the monitor and the audio and video would sync up for the blue, and the same can be done for the orange. But as you will see in my diagram, the local clock for the blue sender and the local clock for the orange sender are different. They started up at different time, and they timestamp the info based on that. And so the receiver can take the timestamps for the 5 o'clock source and knows how to match things together, and do the same thing for the 3 o'clock source and match things together. But I did this to illustrate that the receiver won't be able to accurately match the video from the orange sender with the audio from the blue receiver, because the clock they use for their timestamps, they don't match. The keyword is accurately, because the receiver could do a best effort based on the time the flow showed up at the receiver. So it could still do a pretty good synchronization of video and audio based on when they received the packet. And yes, in this example, there's still no PTP involved. And so so now that we saw IPMX uses timestamp and that many workflows are possible without using a PTP, let's look at why we might want to use PTP. And so all the examples we saw so far work without PTP. Why? Because we were not trying to sync the audio and video from different senders. And we weren't trying to synchronize our monitor output perfectly. So to match flow from different senders or to synchronize various outputs, what we need is we would need all the local clocks to have the exact same value. And the way this is done is by synchronizing all the local clocks to a common clock. When we're talking about synchronizing to a common clock, we call that synchronizing to a common reference clock. And so PTP is the common reference clock used by IPMX and by ST2110. It enables matching timestamp from different sources. It also enables the various receivers to synchronize perfectly their output. So PTP is actually a protocol used to distribute time on the network. It's actually not that complex of a protocol. And IPMX can work, as we saw, with or without PTP. That really depends on your requirements. So let's look a little bit as to why you would want to use, how you could use PTP on your network to make things a little different, depending on your requirements. So if we look at our receiver example from before, but with PTP present on the network, now it's possible to use any audio flow from any, with any video flow and keep them in sync, right? So now we have PTP on the network, our blue and our orange sender are both synchronized to the same time, so their local clock actually match. And so they will timestamp their video as saying, this is my video for 3 o'clock, this is my audio for 3 o'clock. And then the receiver is knowing that both these senders are referencing the same common reference clock. And therefore it knows that it can take video and audio and mix and match and actually line up videos from various sources together, and they'll represent the same moment in time. And so if we had like an example like I have here, where I have a multi-viewer and these were various security camera, then all the different squares would be showing the exact same moment in time type thing. And so when you need absolute accuracy and synchronization between various senders, the way to do that is to use PTP for synchronizing all your senders together. Here's an example where we have multiple receiver and they're able to synchronize their output to generate the perfect video wall display. And so an IPMX sender here is using PTP for timestamp, but the receiver can also use the PTP to synchronize everything. Here I use a single source to keep things simple, but we could have had multiple sources involved and everything could be displayed perfectly in sync with no tearing. I'd like to point out though that as we saw before, this scenario can work without PTP, right? So the synchronization of the monitor would depend on the network topology and the latency on the network between that sender and those various receiver. So do I need a PTP aware switch? Well, of course, if you don't need PTP in your workflow, then obviously you don't need a PTP aware switch. But if your workflow requires a PTP Grandmaster, that does not mean you need a PTP aware switch with special mode like boundary clock. So let's look at where PTP aware switch help. They're useful in achieving super accurate tracking of the PTP clock by follower devices. A large network with lots of traffic might cause PTP message to suffer from a lot of jitter. This means follower might have issue tracking the PTP clock very, very accurately. But with a boundary clock, the follower has a private and direct connection with the PTP master that's in the switch. And so there's very little, if no jitter. And these switches, though, also help in very large environment where the number of followers would exceed the capacity of the Grandmaster to service their requests. These followers also generate a lot of PTP traffic themselves, so that would result in a sizable load on the network. So followers don't load the Grandmaster when they're connected directly to the switch for like a boundary switch. And so follower don't load the Grandmaster in that way, and they don't load the switch with lots of PTP traffic. So if we look at IPMX and see what these PTP aware switches are required for IPMX. So if we review how IPMX uses PTP for a second. So as we saw, IPMX can use the PTP to match flows from different senders. We can use PTP to align the sync of our output monitors. So tracking of the PTP doesn't need to be accurate. And by that, what I mean is like, it's not like we need nanosecond accuracy. to know that the frame of video for 3 o'clock goes from from sender A goes with the one from 3.005 from sender B, right? So we don't need to be nanosecond accurate to be able to match those. We're mostly interested in the visual synchronization. So it needs to appear visually in sync to the human observer. And that doesn't mean nanosecond accuracy is required. Right. So if we look at the load on the Grandmaster that these PTP-aware switches can help with, well, the default value were picked for IPMX to minimize the load on Grandmaster and also to reduce network traffic. So using the default value, for example, if there's like 500 IPMX follower on your network, this would result in about 125 requests per second to the Grandmaster. So it's pretty safe to say that your installation would have to be pretty big. Like I'd say even like it would have to be huge in order to force you to use PTP-aware switches because of the load on the Grandmaster by IPMX device. But of course, if you happen to install IPMX devices on a network that has PTP and that uses PTP-aware switches, rest assured your IPMX device will work just fine. Because the way IPMX works is if there's no PTP, we use the internal clock. But if there's PTP, we use it and everything becomes synchronized. And so we do a recap. Do we need to build a new network? No, it depends on what your needs are. Can I really use any network switch? Well, almost, but use what works for your workflow and your setup. And if you're using a lot of multicast because you have senders that talk to multiple receivers, then you're going to need a switch that supports multicast. But that's true for anything that would use multicast on your network, I think. So it's not a specific thing to IPMX itself. I hear I need PTP Grandmaster. Well, like we saw, we don't really need PTP Grandmaster unless you need the extra synchronization that is enabled by PTP. And do we need a network switch that have the special PTP mode like boundary switches and things like this? Well, it's unlikely unless you have a very, very, very large network with lots of IPMX devices. And so with that, I thank you. That's my presentation. We're running ahead of schedule. If anybody has questions, please go ahead. I'll be happy to answer here or after when we move to the rooms, you can come see me and ask me any question, whether on IPMX or anything else related. Thank you. And stop sharing.
Okay, guys. So thanks very much, Jean. As usual, you took a pretty complicated topic. You made it relatively simple. Good job. Both Andrew and Jean will be available in their rooms for additional questions if anybody's got main stage fright and prefers to have it one-on-one or in a much smaller venue. As well, the other rooms will be open so that you can walk around and get a few questions answered or listen into other people. And we will just take an extended break since we are running a little bit ahead of schedule. So everybody walk around, go to the concession stands, see if you can find a free washroom somewhere. And we'll meet back at 11:55. Tina will be making sure with a few broadcast messages as we approach the time to get us all rallied back for the 2 afternoon presentations, or depending what time zone you're in, the 2 later presentations. That's it for now, guys. Thank you very much. And we'll see you again in about...
Let me answer the question in the chat.
Minutes. Oh, there's a chat question. Sure,
yes, I mentioned up to 25 gigabit, but I did say and beyond. What I meant by that is if you're going to need to do, let's say, uncompressed UHD at 60 frames a second, you're going to use a 25 gig network, right? You don't need the 40 gig network to do that. It'll work in 25. 10 gig is a little bit shy of what's required to do to do UHD at 60 frames a second. Of course, it'll work with any network at the speed that supports whatever you're trying to carry, basically. So 40, 100, beyond, doesn't really matter. IPMX doesn't specify the speed. It's more like the data that you're carrying and how much bandwidth it uses, that specify what